In this video, I will explain how the HeatSeeker 3.0 program applies thermal conductivities to the model. I will explain the thermal properties M file, and I will explain how to make your own thermal properties setup using logical indexing. Be warned, this is fairly complicated, so you may need to watch the video a few times to fully understand it. The easiest way to determine where thermal conductivities are applied is to search for the function thermal properties using Ctrl F. This will show every location that the thermal conductivities are applied to the model. When we take a look at this function, which can be found under the modeling file in the File Explorer, we see that the function uses a switch statement with the property style variable to determine what properties to apply. The most important inputs of the function are TP and property style. To make your own property style, you first need to understand how MATLAB applies thermal conductivities. The location variable is a MATLAB structure variable that contains location.x, location.y, and location.z. These refer to locations on the coordinate plane. In order to define the thermal conductivity, you need to use logical statements along with these variables. The process is called logical indexing. Here's the basic version of a logical statement. If x is greater than 1, the statement will return 1 for true. If it is less than 1, it will return 0 for false. You can multiply this statement by a number to modify the output value. Here I multiplied the logical statement by 0.5. You can see that the output is now 0.5 when true, or still 0 when false because of the multiplication. You can combine different multiplicative logical statements with addition to get different number outputs based on the value of x. Here's a short script that demonstrates an example of this. How does this apply to thermal properties? Well, you need to find a way to write a long logical statement that is equal to the variable Tc so that the thermal conductivities will be defined for every input point. You can imagine the system as querying every single location using a single location variable. Here, you can see part of the stud is defined using the y location. If the y location is greater than the stud upper bound or less than the stud lower bound, the logical statement will be returned to as 1, and that 1 will be multiplied by the wall thermal conductivity. That means, in this case, that the thermal conductivity of the wall will be applied to that specific point that was queried. To create your own property style, copy one of the cases I've already added, rename it, and write your logical statement with the final output going into the variable Tc. You can now reference the property style and model specifications exactly as you wrote it in the switch statement. If you want to check the properties you are working with, consider using the collection number 56, which will give you a plot of the currently selected properties. Notice that the plot may neglect to show certain nuances of the situation if there's one really high thermal conductivity outlier, say a metal plate. This is all you need to know about the thermal properties system. By now, you should understand everything that goes into the setup of the program. In the next video, I will go over how to run the program and many of its important features.